Well, on previous streams, we've been building up this slideshow program. As you can see, we have images with borders and text and rectangular shapes and diagrams. And we can flip around through slides. But I want to start adding features that are helpful for a presentation. And I think the first such feature is going to be having a better cursor. You know, I want to be able to point out stuff on slides, and this tiny little operating system cursor isn't going to do it. We could enlarge the operating system cursor, but that's going to be very operating system dependent. And we're going to want to do things that are fancier than what operating systems know how to do, right? So the operating system cursor generally renders very quickly because, you know, things are optimized for that. But we're doing this game style, and we're assuming that our slideshow is going to be able to, if we want it to, render at least 60 frames per second if we're not trying to save battery or anything. So we're going to have a cool cursor that is animated and interesting and all that. And we may not finish it tonight. In fact, we probably won't finish it tonight because I started the stream really late and I'll get tired, but that's the basic game plan. I am eating a cupcake with a knife. Okay. So the simplest kind of cursor, I think, is just going to be a circle that that moves around, and then we'll build up from there. We'll start with a circle, and we're going to start. I'm just going to make even a new file for this. I'm going to go source cursor. I need to get rid of some of those junk files in that folder. I'm going to save that. I'm going to add it to source control. And I'm going to go to main and load cursor. Whoops, not per. And let's make sure that works. All right, so that compiles. We will go into cursor here and we'll say draw cursor happens once per frame. Okay, we're going to break this into two phases because this is going to be a game style cursor. So we're going to update it at some point in the program, right? And then we're going to draw it at some other point in the program, and those points are going to be different from each other. So we'll go and just add those now, right? So we've got our main loop somewhere, main loop, do one frame. And I'm just going to update the cursor. Why do we read input after drawing the slideshow? That's terrible. Okay, we have to fix that before we do anything. Because you always read input before rendering. Gosh. All right. We'll just leave that incomplete. Then we're going to draw the slideshow. That's in draw. And so we draw to an off-screen buffer, and then we draw that off-screen buffer. This is where we draw the off-screen buffer onto the final render target. And, well, we're then going to draw onto the final render target. There's some subtleties here. So, for example, when I make this big window, right, the off-screen buffer includes or the off-screen buffer just has the image of the slide in it, right? So that's just this middle thing with the black background. But if I want my cursor to be able to go everywhere in the window, then I need to be able to draw it into the back buffer, right? So first we draw the off-screen buffer into the back buffer, and then over that we'll draw the cursor. So that just means that we call draw cursor here. And what's that going to do? Well, we're going to start I'm going to save the space of the cursor in the back buffer space. So we'll say cursor back, we'll just say cursor, yeah. And that's going to be a float because it just is, and the Y, which is going to be a float. Let's just actually make that a vector 2. In pixel units. Okay, so update cursor. For now, we're not even going to try to make the cursor move yet. We're just going to draw a circle in the middle of the screen. So we'll say pause is a vector 2, pause.x is back buffer width times 0.5, pause.y is back buffer height times 0.5. And let's also make a cursor size float in pixel units. Let's call it back buffer size. I'm calling it back buffer just so that I remember that it's because we have several sizes of image target floating around. This is in the back buffer space. We're going to have a cursor position in another space soon as well too. Now, maybe I don't actually want to do it this way. Because what about when we have presenter view? You know, we'll figure that out later. For now, it's going to be back buffer. We might undo this all later, or not undo it, but we might change it to, you know, just the slide or something. Okay. We're going to say so cursor back buffer position is pause, and cursor back buffer size is back buffer height, like 1/20th of the back buffer size is pretty good. Now when we come to draw the cursor, well, let's draw a circle. So we need to set a shader and stuff, and let me, so we have this ARGB no texture and rendering 2D right-handed. That sets up our transform. And now we want to draw a circle. Wow, okay. So I call immediate quad all the time. Wow. All right. I need to make a thing that draws just a triangle. So we'll do that. Immediate triangle. It's like a quad, but it's only got 3 points and a color. And boom. Like that. So here's what we're going to do. We're going to draw a circle. And we're going to say the circle is going to basically be a triangle fan that just looks around because it's got a lot of triangles. And there's good reasons to do this. We'll get into later. So let's say num triangles is 100 for I is 0 to num triangles minus 1. Okay, wait, if there's 4, right, the number of triangles is equal to the number of points. So I'll say d theta is tau, which is 2 pi, divided by num triangles. Theta is I times d theta. Actually, theta 0 and theta 1 is I plus 1 times d theta. So we're taking two different angles and we're recomputing one of the angles every time. Who cares? We're not going for speed here yet. We could store the value in a last theta if we wanted to. All right, so we do theta 0 and theta 1. So let's just say v0 equals get vec2 theta 0. Not quite totally worth making a procedure for, but we'll do it. And so we'll say P0 is center. We haven't defined center yet, right? P1 is center plus R times V0. P2 is center plus R times V1. And then we're going to immediate triangle P0, P1, P2, color. So what's color? Well, for now it's going to be white. Who cares? We're just getting something on the screen. And then we'll immediate flush. Okay, so we need center. Center is just going to be cursor, back, buffer, position. And R is just going to be cursor, back, buffer, size. We basically just made short names for those things. I don't know. Is that everything we need to do? I honestly don't know. Oh, we didn't make get vec2. Let's just put that up here. Theta is a float, and we're going to say CT is cos theta, ST is sine theta, return V2 CTST. That's all. Hardly worth making a procedure. All right, what happens? Hey, we've got a circle in the middle of the screen. How nice is that? How nice is that? So now, let's make it track our actual mouse pointer so that it's actually a useful cursor. Sounds good to me, right? How do we do that? Well, we have some stuff in the so-called standard library. Oh, maybe we don't. Let me see. So there's a Windows API called getCursorPos, and we probably call that somewhere or something like that. Basic Windows, maybe. So basic Windows may only have get mouse pointer position. So this does, okay. This is a little bit of a wrapper around the operating system call that does the annoying Windows things that you want, right? And in Linux, you would do an equivalent thing. All right, that's great. That is amazing, in fact. So when we update cursor, instead of this stuff, we'll just say x, y is get mouse pointer position. What did I call my window? Well, whatever the window is, and true. I want it in right-handed coordinates, so I'm saying true. Some people like left-handed window coordinates for some reason. Window handle. I guess. Yeah. Anyway. So we define this abstraction of window type. So maybe we should use that here. It is an hwind if you're in Windows, but maybe it's simpler to have this have the same function signature across every platform. I don't know. I don't know, man. All right, so I'm just going to say pos.x is cast float x, pos.y is cast float y, right? Hey, so you notice it's lagged a little bit behind the Windows hardware cursor, but that's just how it is. Actually, I don't know if am I displaying the Windows cursor in OBS? Yeah. All right. So this is pretty good start. Well, what are some things that we might want to do with the cursor? So first of all, I probably want to be able to change its size, and I'm just gonna make a value. I'm gonna have 5 settings right now that we're gonna have. But already this is better than like PowerPoint, right? It's like, and probably we also want to turn it on and off. And in fact, probably the cursor should start invisible, and it only pops up if it's visible. And we probably don't want to draw the operating system mouse pointer, right? So let's do all of these things. How about assigning indices to slide items and moving the cursor between them with the left-right keys? Maybe. I mean, I think I have something that I am more interested in than that, but we'll see. Anyway, so let's do the following. We're going to say integer cursor size is an int, and right now integer cursor size max is going to be 5. So integer cursor size is probably 0 through 5 or 1 through 5, right? So now when we update, we're just going to say times O.005 times float integer cursor size, right? Whoops. Undeclared identifier window type. All right. Well, that's interesting. I obviously haven't exported that the way I thought I did. Whoops. Oh, right. I never set integer cursor size. Let's start it at 1. So now we should get a much smaller cursor. Whee! Okay. Now I'm gonna. What did I call the input file? Input. No, it's not called input. What? Where's my read input? Ay, ay, ay. Where do I declare read input? Slow search program. User input. Right. Read input does a bunch of stuff. Handle event. Okay. So I'm still hard coding keys. Eventually we'll make a key map file, but for now I'm hard coding keys. So case 1. Integer cursor size is 1. We're just going to do this. 2, 3, 4, 5. We'll use 6 through 0 for something else. Oh, and while we're here, if it's spacebar, we'll say cursor visible and we'll set that to false. Let's make the default cursor size like 3. Okay, So I'm gonna do the following thing though. Instead of not drawing the cursor, I'm gonna say if cursor is not visible, cursor back buffer size equals 0. I have a good reason for doing it that way. In fact, well, we'll go into that in a bit. And then when we draw it, like, let's just say if we have nothing to draw, we'll return. Okay, maybe, oops, maybe that, I feel like I'm forgetting something. Type mismatch, wanted key code. Oh, geez. All right, that's annoying. I have to auto cast all these because it wants them to be in an enum. Oh no! This is an interesting thing. Okay. I'm going to put this in the compiler to-do list because this is constant, right? It's an ASCII code casted to a certain thing. Let me see if I cast it to a specific type that it knows it's constant. Do I know key code in this scope? All right, well, this is stupid. This is stupid and overly verbose. We'll fix it later. All right, so I hit spacebar, I have a cursor. I hit spacebar again, I have a cursor. All right. So now let's go. I need to find who sets cursor visibility, if anyone. Okay, so Windows has made many stupid API decisions. And one of those decisions is you can't just tell Windows the cursor is visible or invisible. Like, it actually increments and decrements a counter, and that's your only API. So we have this wrapper that does all this garbage, essentially. I don't know, like, it's stupid. I'm gonna just copy this whole file, though. Well, we'll delete that stuff in a second. But, you know, we're gonna want an equivalent Linux version. We're gonna want to internationalize eventually. This is a thing for the languages that we tend to use. You know, it converts the Windows locale code. Getting the contents of a folder, we're going to want that. Getting a file modification time. Getting MAC addresses, I don't know. We may not want that. Constraining and unconstraining the mouse, though, we probably want. And then this stuff, probably not. Let's just see if that compiles. Read declaration. Wait, am I loading this twice? Oh, I'm loading Sokobans already, so never mind. Right, I already have all this stuff, and that was part of the plan. Okay. Forget it, I gotta go delete this now. That's all good. So I can turn on the cursor, I can turn off the cursor. 5, 4, 3, 2, 1. 2, 3, 4, 5. You know, I feel like 5 is a little small. I don't know whether to add a 6. See how big. I don't know. Let's make it a little bit bigger. We'll just make them, we might add more sizes or something, but okay. Times 0.007. How's that? So that's our littler size. That's 5. That seems okay. Okay, now we're going to start getting at least slightly fancy. Like I want to have the cursor be at least a little bit animated. Or not animated, but we're going to want this cursor to feel good. And one step in doing that is just going to be smoothing it out. So we'll do that. So back here, so we want to interpolate between cursor sizes and stuff and not just pop, right? So let's do that. Back here, I'm going to make something called size or desired size. And then I'm going to do the following. I have a function called move toward that I use a lot, where I say, you know, something like cursor back buffer size is moved toward, well, whatever its current value is, which is cursor back buffer size, and it's moving toward desired size at some rate, which is dt, which is the time step for this frame, times some rate, like let's say, well, let's just call it rate. So rate is in pixels per second. Let's say, oh no, no. When we're interpolating cursor sizes and stuff over time, we don't want them to be in pixels anymore, because then if you resize the window, it's going to like interpolate to the bigger and smaller size. We want this number to be in like a unit size, like units of the aspect ratio height or of the window height. Cursor, let's call it unit scale size. Right. And then cursor back buffer size is back buffer height times cursor unit scale size. And this okay. Oh. The radius is equal to the height of the back buffer, which means the circle would be, the diameter would be twice as big as that. All right. So we do that. We've got a desired size. When we hit spacebar to hide the cursor, it'll shrink down to 0. So what is the rate? Usually I like to have a different rate for increase and decrease, but we'll make it, let's just say for now, we'll make it a slow rate so that we can see this happening clearly and make sure that it works. So let's say it takes a second to go for half the screen size. That's pretty slow, probably. No, that's pretty fast. I don't know. That seems like a reasonable rate. We need DT. Really? We don't get a DT here? I guess I'm borrowing that stuff. No, I don't know. Let's see. What are we doing to get a time delta? I feel like I renamed all these variables in the first slide, or in the first episode. I guess not. All right. Yeah, all right. Well, I don't do it there. I do it here. All right, so let's, I feel like I renamed these things, but whatever. Let's see if that compiles. Oh, we don't have move toward. Where does move toward live? I know I have it. Boy, it could be anywhere. Wait, move toward, colon. Slider from 0 to 1, controlled by mouse wheel, generate cursor size from the number. That could be a way to do it, yeah. Adding it to the mouse wheel. We'll see, because we're going to have a number of functions, and we'll sort of decide later like what should be bound to what. But you know, shift plus mouse wheel or something if we don't want to put it on the main mouse wheel. Move toward. Well, that's a weird place to put that, but it's fine. So basically all this does is, hey, you start at A, you're going toward B by some amount, and we just go toward the target number up or down and clamp. That's all. It's very simple. Oh. Right, neither of these is new declarations. All right, so hit spacebar. Spacebar. See how it's growing and shrinking now? 5, 4, 1, 5, spacebar, and it disappears. 5, spacebar, 3, disappear, appear. So that's all working. Now this rate is obviously very slow. So, let's speed it up, and I think the standard rate is just going to be faster, but we'll say if desired size is less than cursor unit scale size rate times equals 3. We'll make that a little lower. So, you know, when you want something to go away, you probably really want it to go away, but you still want to see it go away, right? So space, uh-oh. Oh, there we go. My cursor, there we go. Pretty fast now. Hopefully that's coming across on Twitch though, or on, yeah. I feel like the shrink rate is too fast. Well, okay. Here's what I feel like. I feel like this could be lower. I feel like this should be mildly faster, but if it'll go even faster if we're telling it to go away completely, right? So there we go. So shrinking to 0 goes fast. This goes less fast, so you can see a little more. If the cursor is off and you hit one of the keys, I should probably make it visible. So like hitting one of the keys is probably a shorthand. So now let's hide the operating system cursor. Remember I made this, and we're just going to call this every frame, because why not? Because you never know who decided to change your cursor visibility. Main loop. Do one frame. Okay. Oh, we'll do that in update cursor. Why not? OS show cursor false. Hey, there we go. 5, 4. Any questions about this so far before we do something fun now? Shrink the cursor a bit on click. Yeah, we'll probably do that. Let me start making a list of fun things to do. So, cursor stuff, change color, change size on click. Let me heat up some tea for a second while I wait for any further questions, and then we'll move on and do an interesting thing. Yeah, we're going to do drawing on slides a little bit later on. You're curious if there's any intent to make the slide object properties more like commands so you can stack your rotate, scales, crops, etc. Well, I mean, I don't want to get into weird command language things because those are all kind of terrible. What's going to happen is eventually we'll just have a graphical editor, and whatever makes sense for that graphical editor is fine. Even when I make games, I don't tend to do hierarchical rotates, translations, and so on. I think that's a weird graphics researcher thing. Like, nobody really wants to do that. Above or beyond, I don't know. I mean, I suppose in a slideshow you might have nested groups, and that's how that happens, but it's just, yeah. I mean, I wouldn't design it with that as a goal. I'd design for what is the actual useful thing that I want to do, which is different. Clicking on slideshow elements could make them larger. Maybe also a slight grading effect on selected elements. Maybe. So one thing about the current way that I'm rendering text is that making something larger smoothly with this text rendering method does not really look good because it's a pixel sample thing. Unless you just decide to waste tons of texture memory, which might be a bad idea. But we might change the text rendering later, of course. Anyway, let me go. There's a certain set of things I wanted to get done tonight, and we're partway through it. I want to be able to have multiple different kinds of cursors, right? So I'm going to say cursor type is an enum. There's dot, which will be the type that we have right now. And let's say arrow is the next kind. And I'm going to say cursor type is cursor type. And we're just going to keep update cursor just like it is for now. For draw cursor, we're going to say if cursor type is equal to whatever, case dot draw cursor dot case arrow draw cursor arrow. Right? That's fine. And then draw cursor dot is this. So now we're going to do arrow kind. And I'm just going to set my cursor to arrow to start with. And, well, we're just going to make a quad. And we're just going to start out by drawing a white quad. So we get rid of all these triangles and theta stuff. We still have the color and the position and the size. And I'm just going to say immediate quad P0, P1, P2, P3, color. Well, what are P0, P1, P2, P3? Well, let's say there's a theta. It's 0.0 for now. Well, and then we have a radius. And when you talk about like the radius of a square, you know, it's probably half the width or height of the square, right? So for now, we're going to say this particular thing doesn't rotate yet. Theta is 0, and well, we have our R already. So I'm going to make two vectors called V1 or VA. Well, we already have this thing, right? We already have getVec2. VB is orthogonal to VA. I think that's right. So, yeah. We want it to be orthogonal 90 degrees around the thing, and this gives you that. Okay, and then so P0 is, well, this is a little bit, I don't want to write this down on a piece of paper. Right, so P0 is center minus VA minus VB. P1 is center minus VA plus VB. P2 is center plus VA plus VB. And P3 is center plus VA minus VB. I think that's right. And let's just see if we get a square. Oh, no draw cursor. Oh, geez. I destroyed all my stuff. Well, here's what we do. I thought that I'd copied that whole procedure. This is what happens when you do a thing really late at night. Why am I not? All right. So cursor. I've got all these junk files in this folder. I don't want to stop and. Anyway, we'll diff with what's in the repository because thankfully I checked in. Or did I? Wait, what? Okay, I didn't really destroy very many things. Okay, because I've still got, okay. So draw cursor square or arrow is there. Draw cursor dot, get rid of these things, and num triangles is 100, and d theta is tau divided by num triangles. Right. So draw cursor arrow doesn't do any of this stuff, just does a quad. Undeclared identifier P0. Where? Line 73. Oh, because I left that in. Okay. What happens? Hey, we've got a square. That is great. You might ask, why did I make a square? Isn't that boring? And the answer is, I made a square so that we can texture map it with an arrow. So let's do that now. Go to images, arrow, texture map. What garbage. What garbage? Arrow bitmap. I don't know. What arrow should I pick here? I mean, we'll probably have multiple arrows later on. I mean, we could get this one. Let's get that one. I don't want to. All right. Copy image. I want to rotate it because I want it to be pointing down the x-axis. So let's whip out Photoshop. Creating something off the clipboard. Oh geez. Photoshop. Why is it? Why did this not copy image didn't get the translucency? Save image as arrow down.png. Well, why don't I just do that? Let me see if I can load that. Much better. So, no, let's not do it that way. Let's image rotation, 90 degrees counterclockwise. Ugh, that looks bad with the shadow up. So let's go image, rotation, flip vertical. Okay, it's kind of a bad looking arrow, but whatever. And I want it to what's our image size? 512. So I'm going to scale this up to like 580. And then image, canvas size, 512 by 512. I'm just trying to, that's a little better. And then we'll just move it toward the end. No. Something like that. Okay. We're going to call this one arrowright.png. We're going to add both of these, and then we will do the following. We will do the following. Here, when we call draw cursor dot, we were setting the shader outside. Let's set the shader inside. Because we want a different one for the arrow, we want to use a texture. And then we want to set the texture to the following. I hope I have the texture cat. Let's make sure I initialize the texture catalog. Yes. So map is find in texture catalog, comma, arrow right. Maybe that'll work. Maybe that'll work. It didn't appear to work. Oh, so we're not passing UV coordinates here, which means they're 0, which would be transparent. So let's do that. UV0, 1, 2, 3, UV0, UV1, UV2, UV3. Still not appearing. It's not totally strictly a surprise. Let's just see if we loaded that thing correctly. I mean, it should give us an error if we didn't. It's 512 by 512. It's called arrow right. Folks. well, let's do this. Emacs, why are you so bad? All right. So this should, in theory, hot load, right? So output color dot W is 1. Still not appearing? Interesting. Oh, you know, we didn't necessarily set up, we didn't enable GL blend, which you need to do. But I still don't. Still don't know. Oh, maybe I have to. I always forget what my conventions are. All right. All right, that's affecting, I'm using, okay, this is difficult because I'm using this shader as well to blit the off-screen surface to the back buffer. So if I mess with it, it changes that as well. So we might use, if I don't figure it out really fast, we might use, what's it called? Let me go back to cursor and say, let's go back to ARGB and yeah, let's go back to ARGB no texture and see if it appears. It's there. So it really is something about the texture. So, well, let's do some things. So we'll go GL enable, GL blend, and then what's the thing called? It's called GL blend funk. Something like that. GL blend funk. Oh, this should already be happening. We don't want to do it there, we want to do it here. But should already be happening. Oh yeah. Okay, set the texture. Like, what else do you want from me, man? The UVs are reasonable. We didn't change color mode. All right, let's do render doc. Let's do render doc. Size 5, do a capture, close. All right, should be one of the last, oh wait. Should be there. Inputs, there's our texture map. We've got positions. UVs look correct. Does anyone know how I ask it, why is this not on the screen? Why is it not on the screen? I mean, we outputted this quad. Wait, pixel context. Why is it giving me pixel context for the upper? Oh, that's just because that's where I clicked or something. It's very slow. So this is one of those things where it's like, oh, I'm jamming, I'm getting a lot done, and then now, oh, it's OpenGL. You better not try to do anything. Usually, once you have something showing up on the screen, it's not particularly hard to get a texture to show up. Anyone have ideas? From where is draw cursor arrow being called? It's being called from the same place that draw cursor dot was being called. You didn't see the code. Please show the code again. It's just super simple. I mean, I have a set shader routine that I use for everything, and this didn't help, so I get my texture map, I printed it out to show that it's valid, and it is, and RenderDoc agrees that it's valid. I mean, this is not going to help you to look at it, right? Because it's all just like my code. It's not GL calls. Why did this break? Maybe alpha is 0 somehow. Well, I forced alpha to be non-zero in the shader. And that really, I think, should have done something. Although, like I said, that shader is being used for multiple things, and who knows. Well, I didn't change the face culling between turning the texture on and not, so that should not affect anything. So someone brought up the point that we did do this image drawing thing, but that, where is it? That's actually substantially more complicated. Here. We figure out some points and some UVs, and then we crop, remember all this stuff, and then we rotate. Call immediate quad. Oh, for the border. So here we use even the same overload. Immediate quad with 4 positions and 4 UVs. So all that works. I don't know, man. Maybe it's just like so small that it's mipping down to nothing for some reason. I don't think that would happen. Let's go full screen. No, not that. Full screen. I don't see it. I don't see it. UVs flipped doesn't matter. Why do you think that UV is being flipped? You would still see something. It's not backface culled, and I can prove that to you because if I just change this, although maybe one of these shaders has culling enabled and the other one doesn't, but so here I just changed the shader and now it's there. So I don't know, let me, I can try disabling backface cull just to see what happens. I suppose that could be it. I don't know why it would be, but oh God, that was it. All right. Well, welcome to OpenGL. So now we're in business. We're going to need a better arrow later, but the whole point of all this was so we could do something. So now if you wanted to point at the bottom of something, you could do that, right? But we're going to do something more interesting than that. Why did I run that twice? Remember we made this theta. Let's just say I want to make this cursor rotate arbitrarily for now. So theta is now times tau. That's going to be a faster rotation. That's 1 cycle per second. So let's say times 0.1. Now the thing is, we want to rotate not around the center of the texture because that's wasting texture space. We want to rotate around this point, which is, you know, we want to rotate around okay. So I'm going to say point target is cursor back buffer position, right? That's what we're going to rotate around and what the arrow is going to be pointing at, right? So then I'm going to say direction is get vec2 of theta, and then I'm going to say center is dir times minus what's it called? R, right? Right? Why do I not see anything again? Maybe because I've really messed something up. Wait, but that's just VA anyway, that thing that we just computed, right? So we want to say center is target, I forgot target, minus VA. Hey. Okay, but it's rotating around the wrong point. Oh, you know, when we made theta 0, I got my stuff wrong. Because remember, so we're making theta 0 again. The arrow is supposed to point to the right. And it doesn't, it points upward. And it's totally jacked because it's not... Oh, no, that's working. So, my UVs are wrong or my points are wrong. Okay, it's this. think. No, well, I should have guessed that. Of course, that's only going to flip it vertically. What am I thinking? 0, 0. Oh. This is 0, 1. This is 0, 0. This is 1, 0. That's what happens when I do things without really thinking. Hey, all right. So now we've got that. And then we're going to make theta not be 0 anymore. Hey, so now it's rotating around a point. And why would I do such a silly thing? And the answer is the following. I want to make the ability for you to click on like a point of interest in the slide. And then as you move the cursor around, the arrow stays pointing at that point of interest, right? So we're going to start. Now this is where it gets confusing, because remember, we have multiple coordinate systems happening. Because the point of interest is probably going to be defined in the slide coordinate system, but this cursor is happening in the full window, or the full back buffer size. So we're going to handle the coordinate translation in a little bit, but here I'm going to say point of interest unit scale is a vector 2. And we're just going to put that in the middle of the screen. But even that's a little bit complicated, because we don't want these to be you know what, it does, we don't actually care what this point is, so I'm not going to try to get it right. I'm just going to set it to 0.5, 0.5, and it'll be like somewhere on the screen, right? So point of interest unit scale is there, somewhere on the screen. Because that's really going to be defined by something else in a little bit. When we draw the cursor, so we will say delta pos is cursor, or no, point of interest unit scale minus target, right? So, and if, well, we'll say len is length of delta pos. If len, then we'll say theta is 0, and if len, theta is atan 2 of delta pos dot y, delta pos dot x. So we want to point along that vector, and maybe we should say theta is last theta here so that we don't like glitch if we move over exactly the thing. Potential loss of information in equals, right, because atan 2 gives us a double. All right. So, we're pointing at the corner. Oh, because we're in pixels in one of these. I don't want to do this comparison in pixels. Oh, you know, I'm going to want to draw the shadow separately in a separate texture, because I want the shadow to go underneath but based on the angle, the shadow will be anywhere. But anyway, so so target minus target unit scale. So target unit scale, target. So again, what are my units? I don't want them to be distorted. So I don't just want to divide width by width to get one and height by height to get one, because that'll give you differently sized units in each direction. So since I'm using height as my canonical thing, I'm just going to say IH is 1 divided by all right, so now we're pointing at a point, it's 0.5, 0.5, right? So it's exactly halfway up the back buffer, but then it's an equal amount from the left side, right? So we start at 0 and then we go this way. So we're pointing at like the corner of a square that starts in the lower left corner, which is totally fine. So our next step, which is maybe going to be the last thing I do tonight, I don't know, we'll see. Our next step is the following. I don't even know how useful this is going to be. I thought it was wacky. So when I click the right mouse button, I want to set the place that the arrow points at, right? So I'm going to have a routine called set point of interest. And that is going to do the following thing. Pause is v2x. What did I call it? IH. Oh gee, this is where we need to translate from the window to the back buffer. Let me do that one step at a time. Let me just pretend you're clicking in the back buffer, and the position's going to be off a little bit at first, and then we'll fix it. So I like doing things in small steps sometimes. Set point of interest. So I'm going to say, well, we have this inverse of the back buffer height, x times IH, y times IH, and we'll just say point of interest unit scale is pods. All right, so if I click up here, oh, I don't ever call that. So of course it's not going to do anything. In user input, when we say case mouse button right, set point of interest. All right. So if I click up here, I don't think that did anything. Am I not? Is this not working? Oh, because it's not going to be event type keyboard, I don't think. Or maybe it will. Keyboard, text input. No, I think mouse. I think that should Says mouse. All right, so my set point of interest is jacked. Oh, because I set it every frame. I hope somebody in chat caught that. So remember, before I wrote this routine, I just initialized it every frame. Down here to 0.5, 0.5. So obviously, all right. So here we've got a arrow, and I'm going to click up on the Steven sausage roll guy, and oh, right, no, these are the right coordinates because these are the window coordinates and the back buffer is the size of the window. So I can emphasize the sausage roll guy, I can emphasize this thing, I can emphasize that thing. So that's kind of cool. Like, I don't think PowerPoint does that, as far as I know. Change my arrow size. Can't change the color yet, but we'll get there. We'll get there. Any questions about this? I'm gonna, while I'm waiting for questions, we'll go back to user input and we'll say, well, if people press F1, we will set cursor type dot dot F2 cursor type dot arrow set cursor type later we might set off some fades between the two cursor types or whatever, right? So here we go. That's an arrow. I can point at things. Let's make this big. Woo. That's a dot. That's an arrow. That's a dot. What happens with the interest point after you change the window size? Let's test it. My theory is it works fine because, you know, we saved it in non-pixel coordinates. That's the whole reason why I'm using non-pixel coordinates for a lot of things. So here my point of interest is the sausage roll guy, and let's make the window bigger. And the point of interest is still the sausage roll guy. Maybe you didn't believe that because it's in a privileged position. So let's go to like the letter T down here. That's our new point of interest. And we'll shrink a window. And it's the letter T still. So yes, that works totally fine. It would be nice to be able to press a button to reset the arrow pointer so it stops pointing at something. Well, then what direction should it point? Like just up, maybe? Or test with strange aspect window. All right. How's this? Oh, right, okay. Well, that's interesting, yes. So in a case, this is a weird case where when the window size changes, we need to recalculate our point of interest because the size of our letterboxing changed. That's a good point. Like, it actually works, you know, once this letterboxing size has been chosen, but yeah. Then I change, right, if I change the aspect ratio, it breaks. So that's interesting. Let's let's fix that, because we might as well do this robustly. So I'm going to say so we really, the version of the point of interest that we want to use for drawing is definitely in back buffer coordinates and not slide coordinates. But either way, so like when we do a window resize, we could do it one of two ways. We could keep it in back buffer coordinates, and then when we do a window resize, we recompute those, we take those back buffer coordinates, we convert them to, slide coordinates, do the resize, and then convert them back to back buffer coordinates. Or we just do them as slide coordinates, but we let them be negative, and it's fine. You know what? I'm tired, so this should be simple if I'm awake, and I feel like I'm going to start making mistakes thinking about coordinate systems. So I think we're going to end this here, but we're going to put that here. We're going to say preserve points of interest through aspect ratio changes, and we're going to say let us define points of interest in slides, right? Because you don't want to have to click somewhere, like maybe you flip to a slide and it's already got one. Most logical behavior to me seems to be to only render it as an arrow if there's a point of interest defined, and to otherwise use the circle. Yeah, maybe. It's just I don't want there to be confusion about like, wait, I'm trying to switch to arrow mode, why isn't it doing it, right? I would rather just have an arrow that doesn't point anywhere. Sean says, I'm not clear why ever using back buffer coordinates. Seems like everything mouse related should always just be slide coordinates. Yeah, maybe that's true. It's just that when you get the cursor position from the operating system, it's in back buffer pixel coordinates, so I just ran with that, right? But I think because most entities on the slide are going to be defined in slide coordinates, like it just makes sense to work in slide coordinates. And yeah, so I think that'll be the first thing that we do next time, is do that changeover. How hard would it be to make the slideshow work on Linux too? It probably already works on Linux, or pretty close. Okay, I think